all air systems. What are the applications of all water systems? All water systems using fan coil units are most suitable in buildings requiring individual room control, such as hotels, apartment buildings and office buildings, etc. Now let us look at air water systems. Both air and water processed in a central plant are used for providing required conditions in the conditioned space. That is why you call it as air water system. That means that the thermal distribution system handles both air as well as water. Okay. The air supplied from the central plant is called as the primary air, while the water supplied from the plant is called as secondary water. The room terminal could be a fan coil unit, an induction unit or a radiation panel. Normally a constant volume of primary air is supplied to each zone depending upon the ventilation requirement and load. So these are typical characteristics of air water systems. So let me show a typical schematic of an air water system. So as I have already mentioned, it consists of a secondary water line, okay, and it consists of a primary air duct. That means you have two thermal distribution systems, you can say, one for water, one for air. And this water and secondary water and primary air are processed in the central plants, one plant for secondary water, one plant for the primary air. Okay. Then the processed primary air and secondary water are supplied to room units kept inside the conditioned space. Okay, you can have, in principle you can have several conditioned space. Okay, that means it can be a multiple zone unit. So in the conditioned space we have, as I said, a room unit. This room unit could be a fan coil unit or an induction unit, okay, or a radiant panel or something. And here you can see that in the room unit what happens is the primary air and the secondary air are mixed and they are cooled sensibly. Okay. Then the mixed primary plus secondary air are supplied to the conditioned space for providing the required cooling and heating requirements. Okay. So this is what is known as air water system. In air water systems for summer, the primary air is cooled and dehumidified in the central plant to such an extent that it can offset all the building latent load and a part of the sensible load. Okay. That means what is done in air water system is the primary air is cooled, okay, to such an extent that it can take care of all the latent load on the building. Okay. So that means you have to really cool it to very low temperature, and you also have to dehumidify it. That means you have to supply cold and dry air in sufficient quantity, okay, to the conditioned space so that it can take care of the latent load completely, the latent load on the building, and it can also take care of part of the sensible load, and it can also take care of the ventilation requirements. Okay. So these are the three purposes of the primary air. Okay. Chilled water is supplied to the conditioned space to partly offset the building sensible cooling load only. That means no condensation inside. That means the chilled water, for example, if you are talking about a summer system, the chilled water, which is the secondary water supplied to the room unit, has to take care of a part of the sensible load on the building. It need not take care of the latent load, because the latent load is already taken care of by the primary air. Since the room unit has to take care of only the sensible load, there will not be any condensation of room air on the room unit. Okay. So there is no question of condensate inside the conditioned space. So the problems related to condensate, draining, etc. are not there in air water systems. So this is an advantage of air water systems compared to all water systems, where you have to make provision for condensate draining. Okay. And as I said, primary air takes care of ventilation. And if you are using an induction unit, for example, I said you can use a fan coil unit or an induction unit or a radiant panel. So if you are using an induction unit, primary air supplied at medium to high pressure induces secondary air flow in the conditioned space. Okay. So primary air is supplied to the room unit, which is called as an induction unit, at a medium to high pressure. Okay. So as this medium to high pressure flows through the induction unit, it creates secondary flows inside the conditioned space. Okay. So the room air, that means the conditioned air, which is called as secondary air, flows through the room unit because of the conditions created by the primary air, and primary air and secondary air are mixed inside the room unit, and the mixed air gets cooled sensibly in the room unit, and this mixed air is supplied to the conditioned space. Okay. That is why we call it as an induction unit. Now let us look at advantages of all air water systems. Air water systems offer the following advantages. Individual zone control is possible in an economic manner using room thermostats. Space requirement is reduced as the amount of primary air supplied is less than that of all air systems. Okay, so the ducts of primary air will be much smaller compared to an all air system. And positive ventilation is ensured because you are always supplying a constant volume of primary air to the conditioned space under all conditions. So ventilation is taken care of, unlike in all water systems. And the cooling coil in the conditioned space operates dry, so thereby the problems of drainage of condensate water and possibility of bacterial growth are eliminated. Okay, so these are main advantages of air water systems. Now what are the disadvantages of air water systems? Operation and control are complicated because you have to control both the water as well as air. Since a constant amount of primary air is supplied to conditioned space always, and room control is only through the control of the room cooling or heating coils, shutting down the supply of primary air to unoccupied spaces is not possible. That means even if there is nobody in the conditioned space, still you have to supply a continuous amount of a constant amount of primary air. Okay, so this is actually a wastage, but you cannot help it in this kind of a system. If there is abnormally high latent load on the building, then condensation may take place on the cooling coil of secondary water. That means even though you have you assume that you have taken care of all the latent load by conditioning the primary air, if the outside conditions or the inside conditions are such that the latent load on the building is abnormally high, that means more than the design load, then some amount of condensation takes place in the room unit itself. Okay, so there will be condensation in the room unit, and if you have not provided any means for draining out the condensate water, then there will be problems in the conditioned space. So in air water systems also, even though you do not expect any condensation, still a provision is generally provided for taking out the condensate drain water. Okay, so these are the disadvantages of air water systems, and in general the initial cost of air water systems could be higher compared to all air or all water systems. And what are the applications of air water systems? They are mainly used in exterior buildings, for example for perimeter zones with large sensible loads, and they are also used in buildings where close control of humidity in the conditioned space is not required. That means if you want close control of humidity, you cannot use this system, and these systems are thus suitable for office buildings, hospitals, schools, hotels, apartments, etc. Now let us look at what is known as a unitary refrigerant based systems. These systems are factory assembled and are available in the form of packaged units of varying capacity and type. Each unit consists of refrigeration and or heating units with fans, filters, controls, etc. And these systems are available in the form of window air conditioners, split air conditioners, air to air heat pumps, ductable systems with air cooled or water cooled condensing units, etc. And the capacities of unitary systems may range from a fraction of ton to about 100 tons for cooling. Okay, so these are the characteristics of unitary refrigerant based systems. As I said, window type room air conditioner is one important type of unitary systems, and these systems are available in capacities varying from about 0.3 ton to about 3 tons. And in the window type, both evaporator and condensers are plate, fin and tube type, and forced air convection type coils. Okay, so let me show the schematic of a typical window type air conditioning system. As you can see that it consists of the 4 basic components: the evaporator, okay, condenser, compressor and the expansion device. Okay, in addition to this you have an evaporator fan for circulating the conditioned space air, and you also have a condenser fan for circulating outdoor air over the condenser. Okay, so 2 fans are there, and generally both the fans are mounted on the same shaft and they are run by a single motor. Okay, so same motor runs both the fans, and normally even though it is not shown here, the evaporator and condenser are plate, fin and tube type. Okay, so they are all finned tube type, and it is not shown here again, but normally you have a filter here. Okay, you have a filter here which filters the room air and circulates the clean air over the cooling coil and into the conditioned space. Okay, And normally I think the name window type comes into picture because these units, you can see that it is a single unit, okay, it comes as a single unit, and these units are mounted generally in the windows, okay. Sometimes if you don't have external, if you don't have any windows, or if there is any problem, you can also make a hole in the window, a hole in the wall, and you can mount it in the wall, okay. So one thing you must notice here is that it comes as a single package, so the outside of the wall must be the outdoor, okay, that means you must have external walls or external windows to mount these units, okay. Now larger package units are available in capacities ranging from about 5 tons to up to about 100 tons, okay. And the condensers in the larger systems could be either air cooled or water cooled. So let me show a typical large package unit. So this is a typical package unit with remote condensing unit, okay. So you have a condensing unit here. The condensing unit consists of a compressor, okay, and a condenser, right. Normally the condenser is either air cooled or water cooled, okay. This is air cooled or water cooled. If you are using an air cooled condenser, you may have to have a blower for circulating the air, and these are the refrigerant lines, okay. This is the line that comes from the condenser, it goes to the expansion device here, from the expansion device it goes to the evaporator, okay, where it takes the heat from the surrounding air, and the vapor from the evaporator goes to the compressor, it gets compressed and goes to the condenser, and the refrigerant cycle continues. And this is the indoor unit, that means this is kept inside the conditioned space, where this can be, whereas this can be kept outside, okay, away from the indoor unit, okay. Of course, if you are using a water cooled condenser, it is not necessary to keep it away from the indoor unit, you can in fact keep it along with the indoor unit. The same thing can be in the same package with a distributor for separating out the indoor and outdoor units, okay. And you can also see that you have a limited ducting here. This is the connection for return air duct, and this is the connection for supply air duct, okay. Return air from the conditioned space flows through the filter here, okay, then it gets cooled and dehumidified, and then it enters into the conditioned space, okay. The conditioned space here could be a single room or it could be several rooms, okay, but of course all these are controlled by a single thermostat, okay. That means they serve only single zones, right. So this is a typical package unit, and as I said, larger systems are either constant air volume type or variable air volume type, okay. Most of the unitary systems have a provision for supplying outdoor air for ventilation purposes. The type of capacity control depends generally on the size of the units, and the control system could be as simple thermostat based on off control as in room air conditioners, to sophisticated microprocessor based control with multiple compressors, or variable air volume control, or a combination of both, okay. So the type of control system mainly depends upon the size of the system. And what are the advantages of unitary systems? Individual room control is simple and inexpensive. Performance of the system is guaranteed by the manufacturer, okay. So manufacturer gives the guarantee for the performance, and system installation is very simple and it takes very less time, and operation of the system is simple and there is no need for a trained operator. Most of the time it is simply switching on and switching off, okay. So you don't require a trained operator, and initial cost is normally low compared to central systems. So these are the advantages of these unitary package systems compared to the central systems. Central systems means all air systems, all water systems, air water systems, etc. And retrofitting is easy, okay. So you can easily fit these systems into existing buildings, okay, because they don't really require much space, okay. So as a result they can be used in existing buildings. Now what are the disadvantages of unitary systems? They have several disadvantages. The system is less flexible in terms of the airflow rate. Power consumption is normally higher, that means the COP, typical COP will be lower compared to the central systems, and the total power consumption is also will be higher compared to the central systems. And close control of humidity is generally difficult, particularly in summer. Noise level could be higher because you have the mechanical elements close to the conditioned space, so you can have higher amount of noise. And limited ventilation capabilities, okay, you cannot provide large amount of ventilation using these systems. and the space temperature may experience a swing if on-off control is used as in room air conditioners. Okay, the swing could be as high as 1 to 2 degrees, particularly in room air conditioners. And limited options for controlling room air distribution. Okay, so you may not be able to get perfect room air distribution using these systems. So these are the disadvantages of unitary systems. And equipment life is relatively short, okay, compared to central systems. Now, what are the applications of unitary systems? Okay, so unitary systems are used wherever stringent control of conditions, space, temperature and humidity is not required. That means you are not very particular about maintaining a particular temperature and humidity inside the conditioned space. Okay, so these are ideal for residential buildings, etc., where you don't really require very fine control. And these systems are used where the initial cost should be low. That means if you want a system with very low initial cost, then you should think of using unitary systems. And also where you want to install the system quickly, okay, that means the lead time is very small, then you can install unitary systems. And they can be used for air conditioning individual rooms, okay, to large office buildings, classrooms, hotels, shopping centers, nursing homes, etc. Okay, depending upon the size, you can, as I said, the available capacity varies from about 0.3 tons to about almost 100 tons. Okay, so these systems can cater to a wide range of applications, starting from very small rooms where about 0.3 ton may be sufficient to large office buildings, etc., where you may require as high as about 100 tons. Okay, so these systems can offer to all these categories. Okay, so normally you don't have unitary systems above 100 tons. Above 100 tons, you have to go for central systems. And these systems are especially suited for existing buildings with a limitation on available floor space for air conditioning systems. Okay, so at this moment, at this point, I stop this lecture. I'll continue this with the next lecture. Thank you.